So now we're learning about reference angles. A reference angle is probably one of the more important concepts that we're covering in this introduction to trigonometry. And I find it easier to talk about reference angles visually than with equations. And what you see here is that we have a bunch of angles, and we want to know what quadrants those angles are in, and for each one, what is the reference angle? Now we can fill in the quadrants pretty easily. Okay, let's just take a look at this this unit circle that I drew here. It has no dots or triangles drawn within it because if you notice, these angles are no longer special angles. It's not 30, 45, 60 anymore. These are just plain old angles, and there's nothing too special about them, but you can still use the unit circle to think about it. And let's use this first one as an example, 50 degrees. Well, I know 45 is like that, so 50 degrees is just a little bit more, right? So call that 50. I don't know. That's obviously in quadrant 1. Now what's the reference angle to it? If you remember in class, the reference angle is defined this way. It is the angle between the terminal line and the x-axis. Okay, so that's this right here. There's my reference angle. And you're going to say, hey, wait a minute, I thought that was just theta. Well, in quadrant 1, the reference angle is theta. Okay, they're the same thing. So for this one, it's easy. We would just say 50 degrees. And, you know, you don't need to put that little degree symbol in there. That's not important. Okay, now, let's talk about 160 degrees. Where is 160 degrees? Well, if you think about your unit circle, way over here you have 180 degrees, right? That's halfway around. So 160 is going to be pretty far around. It's going to be like right here or something. Just guessing. So if that's 160 degrees, what is the reference angle? I got over enthusiastic with my erasing there. The reference angle, remember, is the angle between the terminal side and the x-axis. The smallest angle. So I would not, for example, call this my reference angle. That's just theta right there. But the reference angle is the smallest angle between the terminal side and the x-axis. So here we are. There's my reference angle. So if you want to figure out what the reference... Well, first of all, this is in quadrant 2. I think that's obvious. But if you want to figure out what that angle is, that theta with the bar over it, reference angle, just think about it this way. Okay? I go all the way over, that's 180 degrees. I go part of the way over, that's 160. So what's the difference between those? The difference is the amount that I was short of 180 degrees, or in other words, 180 degrees minus 160 degrees. Okay, so the leftover bit, that piece of the pie there that I did not include in my original angle theta, this part, the leftover bit is 20 degrees. And when we talk about reference angles, remember we're always going to the x-axis, not the y-axis. Some people look at some angles, sometimes they go to the y-axis. We'll see an example of why that might be what you instinctively do, but it's always the x-axis. So 14 pi over 9. Well, that's a little difficult to think about. Where's 14 pi over 9 on the unit circle? I would just divide 14 by 9. Okay, so 14 pi over 9, according to my calculator, is 1.55 pi. Which means, let me get rid of this other junk in the way. What is 1.55 times around the unit circle? Well, I know that this is 2 pi. Okay, so I'm not going that far. What else can I say? I can say that this is 3/4 of the way around the unit circle, or in other words, 1.5 pi. You're more used to thinking about it as 3 pi over 2. Okay, that's 1.5 pi. So 1.55 pi is just a tiny bit more than that. Okay, we're talking like something like this. So that is my angle. What is this thing again? Oh yeah, 14. There we go. That's 14 pi over 9. And obviously it's not a special angle. It's not one of those values on the unit circle that we memorize. But let's think about what the reference angle is. Obviously this is in quadrant 4. Okay, because it's more than 3/4 of the way around. What's the reference angle? Well, what's the smallest angle between your angle theta and the x-axis? Sometimes people draw me this one right here. They say, oh, there it is. That's my leftover bit. Well, that's the y-axis. Okay, we're going to the x-axis. So now I'm looking at this part right here. That's my leftover bit. How far did you have to go to get to the x-axis? That's the question. This is your reference angle. And that looks to me like if you had gone 2 pi and then backtracked, that would be this. So this is like 2 pi minus 14 pi over 9. Okay, it's the full pizza pie, the full circle, minus that angle theta that we have over here. So what are our common denominators? This is basically 18 pi over 9 minus 14 pi over 9, which equals 4 pi over 9. And you see now why I like to think about reference angles visually. It just helps me figure out what I have to subtract from what. Now, last one. Can we get rid of all this stuff? Oh, so much to erase. The last one is 13 pi over 12. Okay, and again, it's not a special angle. Where is this thing going to be on the unit circle? Well, think about what 13 pi over 12 is. 12 pi over 12 is just 1 pi. Okay, so this over here, pi, that would be 12 pi over 12. So when I say 13 pi over 12, really I just mean a little bit more. Okay, it's like this. So that's 13 pi over 12. We can draw that as our initial angle, right to there, 13 pi over 12. And where's the closest x-axis? Well, I'll fill that in right here. That's this. Okay, there's my reference angle. So the question is, how much did I overshoot 1 pi? How much am I past 180 degrees or 1 pi? Well, that's going to be 13 pi over 12 minus pi, the amount I overshot it by. And instead of saying pi, I want common denominators. So that's 12 pi over 12, which is just pi over 12. So that's my reference angle here, pi over 12. And you can see, I skipped this, but you can see I'm in quadrant number 3.